would enable you to do event correlation. You should base event correlation on both incoming traffic and outgoing. And a lot of people think, well, why not just incoming? And that's important, but outgoing traffic will tell you if a system's compromised. Because a compromised system will try, let's say, to reach a certain port on a remote system, or try to go to a known bad IP address, something where there's a malicious site, maybe one controlled by the attacker. And event correlation, I don't know about you, but I've actually worked the field of intrusion detection operationally. Any sysadmins here? Any of you? If you've been a sysadmin, you've had to probably correlate data in your own mind. So there is some kind of mental correlation that goes on. The problem is, though, is that mental correlation just can't keep up with the rates of output that you get when you have a full network that's feeding you data. So we have a number of ways to do event correlation. The first is called statistical, and we can use statistical approaches, like, for instance, those of you who know about the correlation formulas. One of the most useful of these formulas is the product moment correlation for certain kinds of data. I won't read the formula off to you here, but you can correlate, for instance, that each particular activity of each particular host at point A and then at point B in the network to try to determine if something systematic is happening. That has to be done pretty much on a per host or per group of host basis, so there are some kind of limitations to applying statistical approaches. Then there's the Bayesian approach, and I did a research study back in 2003 at the University of California, in which I tried to figure out if we could use Bayes' theorem to actually figure out what the probability of an individual host being compromised was. And you simply, if you consider, for instance, that the probability that a given host is compromised is, let's say, 1%, the probability that it's not compromised is, let's say, 99%, because it'll be the complement. And so you can figure out the traditional probabilities if a machine has been compromised, and thus it gives us symptoms of being compromised. That's be given that it really is compromised, versus gives the symptoms that it's compromised if it's really not compromised. The bad news is I ended up with very low output for Bayes' theorem, numbers like 0.15, 0.20, 0.25, not very good in prediction at all. And so I published this once and then moved on to a different area. But there are two really widely used approaches to event correlation now. The first one's called alert fusion. And what happens here is you take the various features that are involved in the various kinds of events that have happened and the information you have, weight each of the features according to how important it is, and coming up with a conclusion that you do have a single event that was generated by some malicious code or some malicious person, and based on how close the observed values meet your expected values, then you can determine whether or not you just tell the monitor, the person who's monitoring your network, that there is one incident here. Yeah, it looks like 7 or 8 different events, but it's really one big related incident. And Valdez and Skinner at SRI International out in Palo Alto have done a lot of work on that. Also, there's other work that's used more statistical approaches like correlation and aggregated relationships between the various outputs that you get from systems. But the approach I want to focus on for the few minutes I have remaining is data correlation. What you do with data correlation is you look at the various features and elements within data to determine whether or not there is some kind of security breach, or at least whether or not an attack had occurred. And there's two main types of approaches for data correlation. The first one I would like to call micro-correlation. Microcorrelation means that you, on the surface, have more than one indication that an event occurred, and these indications are from different devices on your net. And macro correlation, which is based on event chains. Now, if you go back and you look through the CERIAS library, you'll notice that somebody named Florian Kirschbaum actually did his PhD thesis based on event chains and predicting whether or not an attack had occurred based on change of events, only he called them hierarchical events. So these might get different names in different veins of research, but certainly what we try to look at in macro correlation is event A that leads to event B, event B that leads to event C, chains of events that tell us that something's wrong. Now here's an example of microcorrelation. This is the output of snort, and it's told us that we have a remote procedure call port mapper request that constitutes an attack, and what somebody's trying to do is probe the remote procedure call service of a particular machine to gain information that can be used to attack other machines. Therefore, this is not a high priority because this is just a probe. But it still could be significant, but the snort has seen this event. This is exactly the same event as seen by the checkpoint firewall 1. Exactly the same event. I had them sitting on the network, and they both picked up the event when I generated from my vulnerability attack tool. I generated an RPC probe attack. And for those of you who know some of the commands in Unix, it's trying to send commands like show mount -e and things like this to try to find what's mountable, and if it's mountable read-only or mountable read-write and things along that line. Exactly the same piece of data here. In microcorrelation, the fact that you had two different devices see the same event at the same time would cause you to have a correlated event. But I argue with you that that's probably not very complete. It really doesn't tell you very much about the attack, and that another approach might be better, because if you look at attack strategies as used by people who attack systems, there's a number of different phases of attacks. There's the early reconnaissance attacks, where it's just like a burglar, somebody trying to break into your home, rattles the doorknob, tests to see whether the windows are locked and things like this. Then there's scanning, and scanning will tell you which specific vulnerabilities there are. Those of you who know about vulnerability scanning tools, there are tools like Nessus that will tell you where the vulnerabilities are in remote systems. There's also commercial tools like Qualys, and the commercial tools like ISS, now IBM, and Foundstone, and other ones. Then the bad people try to gain system access. If they do that, if they're going to do damage, then they do damage to the system. I've seen some people enter commands like rm minus rf slash start@/ In other words, start at the root directory of a Unix or Linux system and delete all the information, all the files from this point on down in the system. By the way, a student do that to me once in a lab that I was teaching, undergraduate lab. I allowed him to do it at the end of the lab. He's the last one out. And guess what directory he got to? Anybody know? It wiped out everything in / in root. Wiped out everything in dev. It wiped out everything in bin. And it didn't stop until it got to Etsy. And about halfway through the Etsy directory, boom, suddenly system was gone. So that's interesting. Don't try that in your own labs, please. And then the last stage is to track coverage. And what you do here is try to use something like encryption or hidden programs called rootkits so that people can't detect your presence. So here's an example of macro correlation. Here we have event A followed by event B, followed by event C, and this characterizes a particular attack. Event A could be a vulnerability scan, a Nessus vulnerability scan. B might be a successful connection inbound from the source IP address to the destination IP address. And event C might be a successful connection back. That certainly is something that tells you that something's wrong. Because if somebody vulnerability scans you, you then get a successful connection in, and then you immediately give a connection back to that host. That characterizes a fair percentage of patterns of attacks. And again, every event has to be detected by more than one reporting device would be a requirement. And you could be, I would say in my own experience, I could be 95% sure that there was an attack if this pattern of events had happened. Macrocorrelation also tends to lower false alarms because microcorrelation only looks at one event seen by more than one device. But let's suppose that we have an A leads to B leads to C chain of events. If B is a false alarm, think about it. Okay, the microcorrelation will still see A successfully, and it'll be correct. It will still see C correctly, but because B is a false alarm, it has now fired a false alarm, or for the three events, it's wrong on one of three. However, in the case of macrocorrelation, A must be true, B must be true, and C must be true if the event has occurred. Since B was false, then we can say with a confidence that we do not have an attack. And there's another problem. It's a fancy, and really not a very fancy term. It's called zero-day attacks. And zero-day attacks